Okay, so now we're going to talk about the real numbers. Let's get some vocabulary out of the way first. If I say that I want to find the square of a number, then I am looking for that number times itself. So I'm just going to create or finish this chart down here at the bottom, and we're going to talk about the square of each of these numbers. 1 squared means 1 times 1. So whenever I say 1 times 1, I mean 1 times itself. And what is 1 times 1? 1 times 1 is 1. Whenever I'm talking about 2 squared, I'm talking about 2 times 2, which is 4. 3 times 3. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. They've already got 8 squared. 8 squared is 64. 9 squared is 81. 10 squared is 100. They've already got 11 squared on here, which is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. 15 squared is 225. And of course this list could go on and on and on all the way up to infinity. So this is just a few of the common ones, but just understand that whenever I say that something is squared, I'm not talking about it being times 2. I'm talking about it being multiplied by itself. Okay, so then going backwards, we're talking about taking the square root of a number. So on the square root of 1, by the way, this symbol right here is called a radical. And so some people say radical 1, but it's more commonly said the square root of 1. Square root of 1 is just what number times itself is 1, and that number is 1. Square root of 4, what number times itself is 4? That's 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9. They've already got the square root of 100, which is 10. Square root of 121 is 11. Square root of 144 is 12. 13, 14, and 15. There we go. These are just some really common square roots. So the thing is, can you find this on your calculator? Absolutely. So if you are using the TI-30X2S calculator, you would hit, like let's say that we wanted to find the square root of 121. You would hit the second button, which is in the upper left. Then you would hit the X squared button. And if you'll notice, because we hit second and X squared, then what we're really pressing are the numbers that are, or the comment or whatever that's written just above the X squared. And that is the square root button. And so if you want to find the square root of 121, you would hit second, and then the X squared button, and then type in 121, and then hit the equal button, and you should come up with 11. If you need help with this, make sure you ask. Asking on the day of a test is always a bad idea. You need to learn how to use your calculator before the test ever gets here. Alright, so these are things that you could either type into the calculator. So on this top one, I would hit second, then I would hit the X squared button, then I would type in 2, and then 5, and then equals, and you should come up with the number 5. The square root of 121, we've already talked about this, is 11. Okay, so notice these have negative signs on the outside. So that means that I want the negative of whatever this answer is. So first, take the square root of 9, which is 3, and because there's a negative out front, this answer will be negative 3. Now on the bottom one, square root of 144 is 12. Because there's a negative out front, I need to have a negative sign in front of this number. Okay, so this page, this is just giving you some vocabulary the counting numbers start with the number 1. If you're going to count jelly beans, you start with 1, 2, 3. Whole numbers are all of those numbers, but they also include 0. And then integers include all of those numbers, plus they include your negative whole numbers as well. So if I ever want to write any number as a ratio of two integers, so let's look at part A. That's just a number that doesn't have a decimal or a fraction. So if you ever want to turn that into a ratio, you would have to do negative 27 over the number 1. And that's okay, that's perfectly fine to do. Part B, you would have 7 and 31 over 100, but that's not a ratio of two integers, that's a mixed number. So in order to turn that into a ratio of two integers, you have to turn that into an improper fraction. 100 times 7 is 700, 700 plus 31 is 731, and your denominator doesn't change. So a rational number is just a number that's in the form of a fraction. So it's got a numerator and it's got a denominator. And keep in mind that your denominator is never ever allowed to be 0. An irrational number is a number that cannot be written as a fraction. There's nothing that works that you could actually put a good numerator over a good denominator. And more than anything, integers. We're not allowed to use whole numbers. There's just nothing that ever works. So numbers like the square root of 5, there is no fraction equivalent to that at all. That has integers anyway. All right, so we're going to talk about whether or not these numbers are rational or irrational. And let me just give you the short version of rational and irrational. So a rational number can be written as a whole number. It can be written as a decimal that stops or a decimal that repeats. But if you see a decimal that just goes on and on and on and on and on, and there's no pattern to it, then that's an irrational number. That's the biggest difference here. Okay, so on 0.583, because that repeats the 3, notice the line above the 3 means that that number repeats. So there's a pattern. So 0.583 repeating is rational. 0.47 is also rational because it is a decimal that stops. This 3.605551275 dot dot dot, because of those dot dot dots, that means it goes on and on and on forever. So this one is irrational. Okay, so this page, this is just letting you know that rational numbers are kind of in a column all by itself, but the rational numbers, they start off with counting numbers, and then whole numbers include the counting numbers, and then integers include all of those, and rational numbers is the big category here. So irrational is its own. It does not include all of those subcategories, but rational numbers have several subcategories. And so a real number is a number that is either rational or irrational. So here I'm going to show you some numbers that are not real numbers. Okay, on part A, this sucker is not real. And the reason why is that there is no such number that when you multiply it times itself, does it ever give you a negative number. So part A, this would be not real. Part B, because that negative sign occurs on the outside of the radical sign, then this is a real number. And we can say that that answer would be -8 if we were simplifying it. All right, so if I'm given these numbers, I'm going to list the whole numbers. So remember, going back to that list, This list right here, the whole numbers include 0 and your counting numbers. So in this list, the only whole numbers I have would be 8. That's it. That's it. Our integers are your positive and negative whole numbers along with 0. So our integers would be -7, it would be 8, and it would be this one because you would get -8 there. Alright, so my rational numbers are numbers that can be written possibly as a fraction or a ratio of two integers. So -7 can be written as a ratio of two integers because you can place that over 1. The next one is going to be 14/5. The next one will be 8. Square root of 5 cannot be written as a ratio of two integers, but 5.9 can. And then negative square root of 64 also can. Okay, so my only irrational number here is the square root of 5. And all of these are considered reals because we're not taking the square root of any negative numbers. Okay, so it's really important that you are able to locate and label a number on a number line. So what I usually do with all of my fractions is I turn them into decimals, and then it just makes it a little bit easier to plot them on a number line. So 3/4 is 0.75. -1/4 is -0.25. 6/5 is 1.2. -5/2 is the same thing as -2.5. And 7/3 is the same thing as 2.3 repeating. Okay, so now I'm going to label my number line. It's really important that you label it correctly. I always put 0 in the middle. All right, and so now I'm going to start labeling these. So I'm going to put a dot at 4. And if it doesn't fall on a whole number, then you need to label what that number is above it. So like 3/4. 3/4 is the same as 0.75, which is about 3/4 of the way to 1, between 0 and 1. So notice how it doesn't fall on a whole number. So I need to label what that is above it. -1/4 is just to the left of 0, but not quite to -1/2. -3 is over here. It's at a whole number, so I don't need to label above it. 6/5 is the same thing as about 1.2, so it's just to the right of 1. -5/2 is the same thing as -2.5, so it's about right there. And then 7/3 is the same thing as about 2.3, so approximately right there, and label above it. Okay, so now I want to order these, and by ordering I'm going to say which one is the larger number. So typically what I do whenever numbers are negatives is I compare their positives. I compare 2/3 and 1, and I know that positive 1 is bigger than 2/3, but because we're dealing with negatives, that needs to go the other direction. So really -2/3 is bigger than -1. Same thing goes with -3.5. So I have -3.5 and -3. So if I compare their positives, I know that this one's bigger, but because they're both negatives, I've got to flip it around the other way. So I've got -3/4, and I've got hang on, let's do that as a decimal. If I were comparing their positives, I would say that 3/4 is bigger, but since they're both negatives, it's the other direction. And then this one, I've got -2, and I've got -2 and 2/3. So if I were comparing their positives, I would say that this one's bigger, but again, because they're both negative, I flip it around. Okay, so we're just going to locate 0.4 on the number line. Now I'm going to show you a different way to label your number line. And you can just count by point ones if you want. So if I put 0 over here, this would be 0.1, 0.2, 0.3, 0.4, 0.5. So it really depends on how you label your number line. But whatever you do, wherever these tick marks are, make sure that you are using the exact same numbers to space them apart. So if I'm counting by point ones, I need to keep counting by point ones. If I'm counting by ones, I need to go 1, 2, 3, and don't all of a sudden start counting by decimals. So whatever you start with, make sure you continue the pattern. So 0.4 is right here. So on this one, I'm going to show you that we can still count by ones here, even though this is a decimal. So 0, -1, -2, 1, 2, and just place -0.74 approximately where that would go, which would be about right there. But I could have counted by tenths as well. It's just however you count, just be consistent. Okay, this might be a place where you want to hit pause and read through this and maybe take some notes. Okay, so if I'm ordering decimals and they don't have the same number of decimals, I make them have the same number of decimals by putting a 0 at the end or whatever is appropriate for that particular number. And then I start looking at each place. So here I'm looking at the ones place. Those are the same. So I'm going to go to the next number and I'm going to compare those. Those are also the same. So now I'm looking at the 4 compared to the 0. And the 4 is larger than 0, so I would order that to be greater than. Okay, again, they don't have the same number of decimal places, so I would add a 0 right there. And again, I look at the ones place, those are the same. I look at the tenths place, those are the same. And so what I'm comparing is this 3 with this 0. And since the 3 is bigger than the 0, I would say that this one is also greater than. Okay, again, I'm comparing two negative numbers, and I get these backwards all the time. So I compare the positives, and then I reverse it. So I know that if these were positive numbers, 0.8 would be bigger than 0.1. But since these are negatives, it's got to go in the reverse order. All right, so that's it for this lesson. If you have any questions, make sure you send me a message.